Hi, my name is Len McKenzie and I lead the team assessing the condition of inshore seagrass ecosystems across the Great Barrier Reef for the Marine Monitoring Program. Today I'll be presenting the results of the 2019-2020 monitoring year. Seagrasses are an important ecosystem of the Great Barrier Reef, covering 10% of the area, which also makes them of certain global significance. Seagrasses of the GBR are highly diverse, both in species and habitats where they persist, and they're also quite dynamic populations, changing within and between years. Being in the tropics, seagrasses of the Great Barrier Reef are highly productive, and they also play an important ecological role in the goods and benefits which they contribute. Multiple pressures influence the condition of reef ecosystems. These are driven by socioeconomic and climatic drivers, and the associated activities exert pressures that affect seagrass ecosystems both directly and indirectly. On the Great Barrier Reef, the most threatening anthropogenic or human activity to seagrasses has been recognised as agricultural runoff, because it's both diffuse and it covers quite a large scale. In the early 2000s, it was realised that water quality had greatly declined over the past 200 years and that the Great Barrier Reef was in a poor and declining ecological condition. In 2005, the Marine Monitoring Program was implemented and is a critical part of the Paddock to Reef Integrated Monitoring, Modelling and Reporting Program, and underpins the Reef 2050 Water Quality Improvement Plan. One of the key objectives of the Marine Monitoring Program is assessing the condition and trends in ecosystem health and resilience indicators for coral and seagrass in the Great Barrier Reef. Central to this is the concept of resilience. And resilience is the capacity of an ecosystem to absorb those repeated disturbances and adapt to change without fundamentally switching to an alternate stable state. When the pressures are reasonably low on an ecosystem, it may have high resilience. So what that means is when acute disturbances impact that ecosystem, it may decline shortly and then eventually recover to the state that it was prior to the disturbance. If the resilience is very high, it will continue to always return to that level. However, if the pressures are much higher, we find that when we have those acute disturbances, the seagrasses won't recover back to the level they were prior to the disturbance. That's because their resilience is no longer high, and this reduced resilience can start to undermine those ecosystems, and eventually it may change to an alternate state. The key features of a resilient seagrass ecosystem are resistance. So this is the ability of the ecosystem to push back against the stressor, and things such as abundance, the types of species, and the extent and continuity of a seagrass meadow is quite important. Its capacity to recover is also important, and that can be facilitated by the reproductive output and things such as seed banks and the availability of propagules from meadows in the near vicinity. We monitor the inshore seagrass ecosystems in representative meadows across a number of seagrass habitats. They include estuarine, coastal habitats, and also reef habitats, both intertidal and subtidal. We monitor right across the Great Barrier Reef Marine Park, from Shelbourne Bay in the north right down to Hervey Bay in the south, and those 30 locations where we conduct our monitoring cover all of the natural resource management regions within the Great Barrier Reef. At each of the sites that we monitor, we assess environmental and biological variables. The environmental variables that we assess include in situ light and temperature. This is where we're measuring the amount of light that is reaching the seagrass through the water column, and also measuring the temperatures and whether they might be stressing the seagrass. Biological variables we measure at the quadrat and site level. We measured 33 quadrats within a site, looking at seagrass abundance, species that are present, for example. And we also measure a number of variables at the site level, including things like seed banks, reproductive structures, and leaf tissue and the extent of the seagrass meadows. One of the significant climatic pressure on marine ecosystems in the tropics is cyclones, and certainly in this last couple of decades, we've seen increasing frequency of higher category cyclones, and they're having a significant impact on the Great Barrier Reef. Fortunately, in the 2019-2020 monitoring period, no cyclones actually made landfall within the Great Barrier Reef, and the only cyclone that came close to the area was Tropical Cyclone Gretel in March. It remained off the coast and had fairly limited impact to the Great Barrier Reef. The season was also marked by below long-term average rainfall, so it was quite a dry period. And some of the places like wet tropics basins were well below the average rainfall. Associated with that rainfall is river discharge. In 2019-20, certainly it was below long-term medium discharge, and places like the wet tropics had some of the lowest discharge since the monitoring for the MMP was implemented. Another environmental pressure is the exposure of seagrass to turbid waters. In 2019-2020, the frequency of our seagrass sites exposed to brown or sediment-laden turbid waters was slightly above the long-term average, only marginally, in all regions except for the Fitzroy. The frequency of exposure to green or high nutrient turbid waters was at or marginally above the long-term average. Some of the largest exposures occurring in Cape York and also Mackay Sunday. In situ light, we measure with light loggers within the seagrass meadows at 25 locations. And in 2019-20, the reef-wide average for daylight reaching the seagrass canopy was actually above the long-term average. However, that was not across all regions. Unfortunately, in Cape York in the north and Burnett Mary in the south, both of those NRMs had the light over that period was below the long-term average. Water temperatures we measure within the seagrass canopy at each of the sites, and 2019-20 was warmer than the previous period, but fairly similar to the reef-wide long-term trend. Elevated seawater temperatures, so this is where seawater temperature gets above about 35 degrees Celsius, can certainly stress seagrass plants, and if it gets too hot, for example, above 43 degrees, it can result in plant death. In 2019-20, the number of days where the temperature went above 35 degrees was certainly higher than the previous monitoring period and only slightly above the long-term average. Mackay Sunday, seagrasses experienced the greatest number of days where the temperature was quite high, and those high temperatures were really only experienced in the most southern regions, which all had at least one day where it went above 4 degrees Celsius. The hottest seawater temperature recorded within our seagrass sites was 41.1 degrees in Mackay Sunday. And the last of the pressures that we examine is epiphytes and algae. So epiphytes are the smaller algae that live on the surface of seagrass leaves. And in the monitoring period, epiphytic cover was above the long-term average at all sites, except for the reef intertidal. Macroalgae, however, has always been pretty low. It's a little bit higher though in reef intertidal, but overall it was not significantly different from the long-term average. So how do these pressures then affect our seagrass condition? Well, first is our indicator is abundance, and we've been monitoring seagrass abundance since 1998 across the Great Barrier Reef. The marine monitoring program started in 2005, and prior to that, there were a number of legacy sites. There were fewer number of sites. But once this program was implemented, fairly soon afterwards, we experienced a major tropical cyclone, which caused a slight depression in the abundance. However, the seagrasses were fairly resilient and within a couple of years had recovered from that. From about 2009, however, there were a number of consecutive years with above average rainfall. And in 2011, the early part of that year, the reef was actually impacted by tropical cyclone Yasi, which was one of the largest tropical cyclones to impact the Great Barrier Reef in recorded records. After the impact of those rainfall events and Cyclone Yasi, seagrass then went into recovery mode. It was very slow to recover. It didn't actually get back to its pre-impact abundances before, in about 2017, we started seeing increasing discharges for a few years and a couple of tropical cyclones impacting the reef. What's interesting is if we overlay a plot of the discharge from our rivers along the Great Barrier Reef, and you can immediately see that during periods of large discharge events, we actually see low seagrass abundance. So there's a quite close relationship there. Seagrass abundance in all of the NRMs was well below the long-term average in 2019-20. We did see some increases in Mackay with Sundays, but the greatest decline was experienced in the Burdekin. This is still a legacy of the floods and low light experienced in early 2019. The size of our seagrass meadows certainly changes within and between years. So it is more extensive during the late dry period, just before the wet, and then declines after the wet period. And we do find that large disturbance events such as floods and tropical cyclones can have significant impacts on the extent of seagrass. However, in 2019-20, the extents of our meadows were slightly higher than the previous year, so they're continuing to recover. And overall, they were similar to the long term. Unfortunately, there was declining in our meadows, about a fifth of our meadows, particularly in estuary habitats, the Burnett Mary and the reef habitats in the Fitzroy. The species composition within our seagrass meadows, we find that during disturbance events, their meadows become more dominated by colonizing species. That was particularly evident between 2011 and 2013. However, during 2019 and 20, the proportion of colonizers decreased in all our habitats, with the minor exception of the coastal subtidal, and remained above average at a fifth of the sites. How the seagrass meadows respond and their capacity to recover is driven by their reproductive status. And we notice that the reproductive effort is different between our habitats, so it's much higher in our coastal habitats than it is in our reef habitats. And in the recent monitoring period, the reproductive effort decreased at coastal habitats and pretty much remained low and unchanged across all other habitats. The seeds in the seed banks of our seagrass meadows have also been declining. They not only differ between our habitats, but since about 2018, our seed banks have been declining and are now absent from about 40% of the sites that we monitor. Overall, our reproductive status is well below the long-term average. And most recent period, both Burdekin and Mackay with Sundays increased, while the wet tropics declined. Places like, regions like Cape York, Fitzroy, Burnett Mary, all remained well below the average reproductive status for the fourth consecutive year. We also measure the leaf tissue content. So this is to particularly look at whether the amount of nitrogen in our coastal environments is impacting our seagrass. And in 2019-20, we noticed that the majority of the NRMs improved slightly, but there was a decline in Cape York. Overall, this indicates that Cape York and wet tropic were well below the GBR long-term average, indicating possibly higher nitrogen in those environments and or lower light. So overall, the condition of the Great Barrier Reef inshore seagrass ecosystems in the most recent monitoring period have shown a continual decline since 2016-17, and that's been driven by losses in all of the indicators that we measure. And overall, the condition remains unchanged, well below for the third consecutive year. To summarise the 2019-20 monitoring year results, in terms of the climatic and environmental pressures, generally they were pretty low overall. There were no cyclones, less rainfall in the catchments, and as a consequence, less river discharge. Above average light was available at our seagrass sites, and sea temperatures were fairly similar to the long term at our seagrass sites. However, that's not consistent across the reef, and we do find some higher pressures in individual regions. For example, in Cape York, we find that there is green, or the very nutrient-rich waters were much higher, and there was lower light available for seagrass growth. In the Sundays, turbid and nutrient-rich waters were slightly higher, and the number of days where sea temperatures were high also increased. In the Fitzroy, slightly higher nutrient-rich waters and a few more higher sea temperature days. And in the Burnett Mary, seagrass experienced lower light available for growth and slightly higher sea temperatures. In terms of the seagrass ecosystem condition reef-wide, there are certainly indicators of reduced resilience due to the ongoing cumulative impacts and the pressures, and they include below average abundance overall, long-term abundance declines in Cape York, Sunday, and the Fitzroy regions, lower than average composition of foundational species at nearly a fifth of all the sites, declining meadow extents at nearly a fifth of sites, below average and generally decreasing reproductive effort. There's low and declining seed banks and slightly higher than average epiphyte cover. It's not all bad news though. There are some bright spots of improvement. They include increases in abundance at a third of the sites, and most of those are in places like Sundays, which is recovering from Cyclone Debbie in early 2017. Nearly a third of the meadows continue to expand in area or become less fragmented, so that increases their resistance. And there is increasing reproductive effort at a third of the sites, showing a slight improvement in their capacity to recover. So overall, the findings from our most recent year of monitoring suggest that seagrass ecosystems in some regions, such as Cape York, Fitzroy, and Burnett Mary, may be more vulnerable to adverse or severe disturbances in the near future, as their resilience is being compromised. If you would like more information on the program or the results of our monitoring, please visit the Great Barrier Reef Marine Park Authority website, where you can find all the publications from our years of monitoring. And you can also visit the Seagrass Watch website, which gives you a bit of a more detailed look at individual sites. Thank you.